as well. So like Mustafa said, you need to assess your workloads and make proper adjustments. So if you have some applications, then and in certain cases, if the applications are healthy, so in certain cases these applications will actually need to be just moved to the cloud. So just rehosting, and that's the, well, of course, after the reassessment and after having a sandbox environment, having tested this, then we should rehost. In other cases, we might think about introducing some minor changes to the code, so refactoring in this case, or probably re-architecting or rebuilding the entire application. So depending on how the application performs and depending on the other factors as well. For example, what are the dependencies and so on. So the three scenarios are here available: replacing, retiring, or retaining the existing application. So and approaches. Should you not design specifically for the cloud? Were the questions? Yeah.
Okay, we'll get to that in a minute. Let's just keep it for a second, and because one of the next bullet point is actually addressing that.
Exactly.
Okay, so basically, you also want to assess your workloads and make adjustments. When we're running like all the workloads in the local environments and running them in the cloud, there's quite a difference, because we like to get comfortable with the resources we keep on-prem. Like we like to have enough memory just in case, enough disk just in case. And basically, especially when we have a big data center on our hands, no one really cares how much resources you dedicated to a single virtual machine, unless the whole data center is running out of resources, because those resources are already bought, they are already paid for. If we're not using them, then they're just going to waste. With the cloud, it's quite a different story. Like, you're paying for what you're using. You bill per minute of running things. And just like if we had a huge virtual machines for specific system, just moving them as they are, like assuming the same amount of resources is going to run in the cloud, can turn quite expensive, because we are keeping a lot of resources on-prem to be covered in case of increased workloads, like predicting what's going to happen in the next period, like 6 months to a year, because acquiring new resources, getting additional memory or CPU or disk can take quite some time, especially in large organizations. So we kind of like to keep things cool, like have enough just in case. In case of the cloud, we have a quite different situation where we'll bill for everything. Like, if you're not using it, we are paying, like, money is going to waste. So we don't want this situation. On the other hand, like, acquiring something additional is just a matter of a couple of seconds, or just doing a couple of quick clicks, or creating a custom script. So you're getting resources whenever you need them, as much of them as you need them, and you don't need to over provision things before you actually require things. Next thing is this: the question is that should we design specifically for the cloud? And that is like exact question. Like I said, don't lift and shift. That's like worst case scenario. What you want to do is refactor and redesign. You want to use the best out of cloud. When you're moving virtual machines, like doing that lift and shift, like pick up what I have here, move it up there, and it's running, it's all fine. It will work, like it will work. But you're not getting the most out of cloud. There are a lot of great, now, for a long time, we had a platform as a service services that can help us achieve much more. Nowadays, like serverless is really a thing that can take that even one step further. And you want to use all those cool things that cloud is offering, and it doesn't stop with PaaS and serverless. We have things like artificial intelligence, there, machine learning, insanely good data processing, and so on, that can help you take things to the next step, like enhance your applications, get them better, add additional cool things that they can do in cloud that you can never achieve in on-prem environments. Basic one is here, don't transfer your problems to the cloud. Like whatever you had on-prem, like all the systems that are constantly running, if you think that cloud will solve your problems, it will not. You need to adjust. You need to fix the current issues. You have to redesign the things, like make them better suited for the cloud. I've seen a lot of people like in situations where people were running, I don't know, .NET 2.0, and it was running. It was fine. And you can move it to the cloud as a virtual machine, and it will keep running. But is this really the scenario that you want? What are you achieving exactly? Because you're not getting any additional benefit that cloud is offering. Like you're just keeping it as it is, maybe prolonging the application life for a little bit longer, but it's just like buying a few extra months or a year.
And just a few moments to address a comment. So lift or shift first then? Well, it depends, because we have a few scenarios. Well, I'd like to suggest that lift or shift, like Mustafa said, in most cases is not a good scenario, because any bad design will be emphasized as well as good design. But we have few architectural choices here. We either have the option to rehost, so lift and shift to Azure infrastructure as a service, for example, without application changes. But we should do that. I suggest that we do a proof of concept, or that we do that and test it in a sandbox environment, in a test environment, so we can see how the application performs. And the other things that we could do, we could refactor the application, so we can introduce minor changes to run on a cloud provider platform if we have some requirements. And the next step would be re-architect the application, so modernize it for platform as a service, for example, for and updating the existing code base. And at the extreme case, we will need to rebuild completely and throw away and build a new optimized application to run cloud native. So don't throw it away immediately, just test it. So if it works in a sandbox environment, if you identify that there will not be any issues or bigger issues that you don't know about and can't resolve, then yes, lift and shift, but only in this case. And speaking of which, like I said, I have one client that just lifted and shifted in a few months, and it was the rush lift and shift rehosting, but they knew the outcome and the negative sides, and they have extensively planned the how to remediate for that, and what are the post lift and shift actions and so on. So to have the optimized cloud environment.
Okay, and as we said, migration will not magically solve all your issues. Like if you have problems, just running away from them and moving to cloud will not help you. Thing that we need to consider is don't move to Azure just because. Cloud is a big thing. It's not like here for like a year now. It's not the latest trend. Everyone is aware that cloud computing is a big thing. Like more and more companies are running, like I don't know how the current percentage, but we are closing to 70% of the companies having at least something running in the cloud. So basically, it's a big thing, and everyone is jumping on board. But don't move to cloud just because everyone else is doing it. Like, do your research, try to figure out why you want this. Maybe Azure is not the perfect solution for you. Like we have a couple of, like, when we compare major competitor, like major market share is from AWS or Azure, and they all have their pros and cons. Then we have a GCP that is next to them, but not even close to the first two. But now they're offering some pieces that are kind of cool and unique for them. So do your research. Like, what are you trying to achieve with the migration? Like, what is your final goal? know what you want, what your current issues are, and based on that, then make a decision on what cloud is best for you. Because if you just move to any of the clouds just because someone else did it and you want to be cool and do it yourself, it's not a proper move. You might are happy, you might like take a chance and move to the correct cloud provider by that chance. There's a nice percentage that you might guess right, but try to do your research and understand why are you choosing this cloud provider, why is this cloud right for you, what will it bring you, how it will improve your application.
Now that you mention it, Mustafa, it's I work with a client of mine. Well, I have two examples. One client was one company, and rather big company was rushed to actually rushed to the cloud, and because the competition went, and without investigating a little bit. So at the end, they spent more money to resolve the issues they had when they moved to cloud because they actually haven't done any investigation. On the other hand, I had one client, one company that we saw had not apparent benefits for moving to the cloud, and when they had started a cloud journey, I asked them, why are you moving to the cloud? So they said, yeah, one of our competitors, biggest one, have moved to the cloud, so we wanted to investigate what is in for us. And what they did, they had a department, a few people that investigated the cloud benefits and were working with some of the services for a year. And while at the beginning they hadn't identified any benefits, at the end it turned out that at least 10% of their services could be moved to the cloud and changed with the cloud services. Not 90, not 100%, but well 10, and they actually saved money. But they've taken time and they've investigated in that. So investigate what will help you and how. So do you have real benefits in moving to the cloud? So the cloud is not silver bullet, so you should investigate whether because it's working for your competitor or friends or similar companies doesn't mean that it will work for you. So you need to investigate that.
You want to take the next one?
Yeah, and of course you need to understand the broader picture, how services work and integrate, and there are a lot of hundreds and I wouldn't say thousands of services, different cloud vendors, not just Microsoft, but AWS and Google Cloud Platform and Alibaba and so on. So once we have one set of services, one application that is tight and integrated and consumes and works with different services on premises, but the same thing, the services that perform the same thing in the cloud probably won't work at the same way. So we need to understand the broad picture, how these services actually in the cloud work and integrate, whether they're supported, do they support each other, are they in preview, how their performance is, and what are the costs. Maybe the cost will outweigh the performance, or the performance will outweigh the cost. So maybe a certain database or some messaging service is not supports like 8 of the 10 features that we need, but actually the 2 most important, the 9th and 10th, actually are the deal breakers. So and actually can prevent us to move to the cloud, because the refactoring the application could be more costly than actually implementing the messaging service, for example, for these 2 lacking features. So we need to understand the broad picture, how these services work, how these services integrate, and whether what will be the impact on the overall infrastructure. And Mustafa, do you have anything else to say about that?
Yeah, basically, just like if
So
this is like especially tricky when you're working with existing solutions and you want to do some kind of enhancement, improvement. If you're like aiming to resolve a specific problem, you need to know like how your current services, like the services that you're currently using, uh, are working together, and based on that, you can like make an adjustment and like. Include either third service or remove something from the solution that might work, make it work better. So that's like, keep in mind that you want to know exactly how services work, because a lot of them can achieve the same thing, but bottom line is how it fits in with your requirements and your solution.
yeah, sometimes you have also you can resolve one problem in 5 different ways, and of course 5 different implementation schedules, times, and costs, and everything else. So you first need to know what are the options, whether you need the infrastructure, platform, or software as a service, or something in between, and so on. So don't design your solution to be cool, design to do the job, as we
Yeah,
were.
this is the favorite mine.
Exactly.
Like, don't design. This is like a really tricky
Yeah.
thing in cloud, and this is like a trap that people often fall into, because we have all those great new services. They do this, they do that, and we often, like, people in IT are kind of, we are kind of like enthusiastic about new stuff, like improvements, like new technology, and we kind of get to be carried away on it, like trying to use the latest and greatest. And it's fine, like for some situations it might be a perfect fit, especially we all took all the previous steps and like investigated, so like how the solution works, like does it fit what we need, and so on. But very often people are kind of like blinded by the latest trends, and they just want to be on boat and say, okay, yeah, when we are discussing things at the IT conference, everyone wants to say they're using serverless, everyone wants to do Kubernetes, everyone's like crazy about NoSQL databases. And it's perfectly fine to use them in certain situations, but you have to understand, like, what is the requirement? What do you need from your solution? Like, if you're like on Azure for the NoSQL databases, we have plenty of different solutions. The most popular is probably Azure native Cosmos DB. That is really great solution. It works with different APIs and stuff, and it's really great. But do I actually want to use NoSQL solution when I need transactional consistency, for example? Or Kubernetes are great when we are designing like microservices and like have this great API structure, and we know what we're doing. We have this robust system with a lot of different APIs and stuff. But if you're designing a simple website, is the Kubernetes the greatest solution and most simple one? So you really want to know what is required from the solution, like what is your architecture, and based on that, you can actually decide on how to choose right services, because in some cases the latest is not the best solution for you. For example, one of my favorite services in Azure of ever is an Azure App Service. It's been here for, I don't know, from the beginning, I think. Like, this is one of the first Azure services, one of the first Azure offerings, where we have like abstraction of IaaS server as a platform as a service. And it does a great job in certain situations. Even like today it supports containers and stuff, but if I had a robust microservice architecture, I would go with Kubernetes. But like Azure App Service can do a great job for a lot of different things. So you want to like think about it and understand what you actually need and use the correct services for it. Not, don't use the latest, use the best for what you actually need. Okay, hidden traps, and there's plenty of them in cloud. So, Sasha.
Yeah, be ready for learning and constant changes you need to keep up with. So when both Mustafa and I were are in Azure from the very beginning, since the public and private preview, and we worked with Azure service environment as well, and manager. And what we have to say is that the only constant in here is the change. So be prepared for the new services, new features, new capabilities, and but this is not just the Microsoft Azure issue. It's everyone's issue today. So in order to be ahead of the competition, in order to be innovative and have the latest and greatest, of course, cloud providers, and integrate and innovate and introduce a lot of the new functionalities. So user interface changes and functionalities, and moving things around and as well. So be prepared for prepare for changes, but not just that. And I suggest that you follow the relevant blogs and the documentation as well. So today also the changes and roadmaps are also included on the documentation site, not everywhere, for every product, but for most of them, and also but I mean, it is the new normal of today. So it is not similar to the server or desktop operating systems. Even these change from time to time, more often than they did before. So, but that's the learning that you have to do. So please invest in it, and it's not wasting time, not just in learning about. I'm not talking about the user interface changes, but actually the changes about the functionality. So the functionality, the performance, the prices change. Well, fortunately, we've been witnesses of the price drops as well. So I remember one very
just to like
price
say
drop.
here, I don't remember price rising like ever.
Yeah. Well,
I don't like
I'm
actually
not sure about
remember
that,
a service being like more expensive at certain point. That's like they might introduce new tier that will make it like look more expensive, but it's because it has more resources attached. But like
yeah.
most of the price changes are kind of for a better, except when they're in preview, but we'll get to that one later.
Yeah, exactly. I mean, it's the economies of the scale. So as any cloud provider has more and more customers, potentially has the possibility to be have better prices. And of course, the hidden traps would be also understanding billing and subscription and choose wisely. Why? Because it's when we committed. When we bought our servers or computers on premises. So we committed up front, and we planned for 5-year or 10-year or 7-year capacity. We estimated the CPU memory and disk spaces as well. So we committed to that, and we don't need to think a lot in advance in the cloud. Yes, we still have to have plans, but it's easy to upgrade and to increase CPU or disks and add to that. But also, it's very important to understand billing and subscriptions. So we have different types of billing. We have different types of subscriptions. Subscriptions is actually the way how the cloud provider actually, in this case, Microsoft Azure, bills you. We have different options that can save a lot of money and a lot of resources. So committing upfront is one of the very nice options, where we can commit for a year, 2 or 3 years upfront. So we pay a little bit more, but on the reduced price. So up to I think roughly 50%, we can save a little bit of around 50% on that. And if we have the option, if we have some software assurance or some other ways, we can also move our licenses in the cloud. We can save there as well, save on the licenses. If we choose to go with the for example, with the open source, in some cases, open source is better than the proprietary operating system, but in some cases not. So we can save for the licenses as well, and etc. So there are different options. For example, like enterprise agreements and open subscriptions, etc., etc. So we have options for different. How can we spend in a different way? The most basic would be just entering the credit card number and being billed at the end of the month. But we still have the option also to save substantially in the cloud. So choose wisely, since everything that we provision in the cloud is going to cost us. So I think the good rule here is 80-20 rule. So 80% of planning, 20% of execution. Plan in advance, because a good plan and good pricing, good infrastructure plan, good application plan, and good architecture plan will actually save you a lot of money at the end. And
on
not
this
only
part for the billing, I would just add from a couple of years ago, we have options for the reserved resources. If you buy for virtual machines, app services, SQL databases. So basically, doing reserve resources when you're committing that you're going to use the same type of resource for 1, 2, or 3 years, it can give you additional discount that can save you a lot as well. So that's also something to keep in mind. Now, next part is understanding quotas and regions.
Definitely.
Now, this part is like, first, each subscription comes with certain quotas. You're limited by the amount of resources you can create in certain regions, in certain data centers. So you want to know that you cannot like create infinite number of Azure SQL databases in whatever region you choose. On the other side, like regions are also very important, because this is like the depending on region that you're choosing, it's how your application is going to operate. And basically, you always want to choose a region that is closest to your customers, to your end users, because that way you will provide the best performance, least network latency. So basically, always don't choose the region closest to you, choose the region closest to your customers. But also, when it comes to regions, there are certain limitations, like all types of resources are not always available in all regions. So keep that in mind. This especially applies to newly opened data centers, newly announced like Azure regions. When they just open, they usually have only core services and then expand on that and add additional over time. But like all services are not always present in all the data centers. So keep that in mind. Know that like when you're choosing the region, you want to choose the region closest to your customers, but also the region that supports everything that you're gonna require.
I mean, speaking of which, yeah, sorry.
Yeah, basically, I wanted to go to the next, but if you have to add something on this, go ahead.
I just wanted to say that we know that the things are easily provisioned in the cloud. So to create a virtual machine or the network, you need a couple of seconds or 30 seconds or a minute. And if you're not satisfied with it, you just delete it and create a new one. But once the things are in the production and once the things are settled up and up and running, and then it's very hard to decommission a server or network or any other service. So planning is it's needed, and especially because the quotas and depend on billing and subscriptions and vice versa. So like Mustafa said, yes.
Okay, this is the one I mentioned a few minutes ago. Avoid depending on services in preview. This is like a big no-no. I got burned a couple of times, and I'm like really passionate about this one. So basically, first of all, like Adding a service in preview in your production is a really bad idea in any case. Like, don't do that. If anything goes wrong, preview services are not supported. You cannot open a support ticket. You cannot get any kind of help from Microsoft. If something goes wrong, you're on your own. They will just tell you, yeah, that's in preview. That's for you to play with it. On the other hand, like when you're only developing project, like you still like developing something and you saw a cool service in preview that might help you, and you start working with it, again, don't. Like, services in preview should be just for that, to do preview. Don't include them in any of your current projects. First of all, there are two catches there. So first of all, you never know how long a service is going to be in preview. I've witnessed services that were in preview for over 3 years, and I've witnessed services that were in preview for quite some time, and finally were pulled out and never released because Microsoft decided there's a better way to do it, and they just cut that development. They stopped it and started working on something similar that will be better in their opinion. So that's kind of like a big issue. And the second one is the services in preview are not defined in terms of pricing. So you never know what the final cost of the service will be. It can turn out quite expensive, and you invested a lot of time, your project depends on it, and now you're in the situation that this kind of like service costs too much, and it starts to be a deal breaker for you as well. So try avoiding them, using services in preview at any cost. Try figuring out something else. These are just for you to try out, to see, like, to give you an idea what it's all about, and maybe plan for the future projects, but don't use them in any of the current stuff. Okay, don't rush. Sasha.
Sorry, bad cough. Yeah, you have, sorry. Please, can you take this one?
Sure. Okay, design and plan your identity approach. So basically, identity is really important part of everything. Like, this is like where everything starts. Like, authorized accesses, who can log into what, use what kind of application, complete authorization process depends on it as well. So like, once I log in, what can I actually access, and so on. So basically, you want to think about how you're going to approach this. Basically, I've seen a lot of problems here, especially with large companies when they just do identity sync. This is probably like identity sync if you're, and most companies did have some kind of identity, probably Windows Active Directory on-prem, and they want to use same identity. That's perfectly fine because it helps users, like having a single identity, same username and password for whatever they're using on-prem cloud services. Even like third-party vendors. So basically, you want to keep your identity and you want to concentrate as much stuff around it as possible. But also, when you're doing these kind of things, you want to rethink how you're doing it. Like, I've seen a lot of issues with syncing everything like they had, including stale accounts, disabled accounts. This creates a big security issue for you, because when you're just syncing everything, including those problematic stale or disabled accounts, you're creating big attack surface for you. Like, there's a lot of accounts that who knows has access to or had access to over the years, because you have accounts that were like disabled, or not even, like, people left company years and years and years ago. You never disabled their accounts and just syncing them to the cloud. Now you're opening a Pandora box that can really create a lot of different issues for you. Sasha, better now?
Yeah, and you have definitely to consider connectivity. When we were on premises, when we had all the things on premises, so we had different issues, but we didn't have the connectivity issues because it was all there. And now companies and architects often neglect or forget about the connectivity, or don't devote a serious thinking about it. So they incorporate and install Architect the disaster recovery, backup, and everything. They back up to the cloud, disaster recovery in the cloud. Everything is in cloud, scaling in the cloud. But then they forget that everything is it's actually hanging on a very thin thread, and that is the one cable and one VPN device, or one ISP provider, or one connection. So if you have a mission critical, or you have a company running, or enterprise, or whatever your company is running in the cloud, so you first need to also to consider connectivity, and not only this, but also the issues when you have such connectivity. So typically, what you need to see the to address the quality of the existing connectivity, and I'm not speaking about the quality that it's surfing the web quality. It means the quality when multiple users connect, when you have databases connected, when you have different protocols connected, when you have one VPN device that it's connected, and then you need different channels, different throughput, performance, and so on. So once you move things in cloud, or migrate, or either completely or nearly completely, or in some percentage, then the things are definitely going to be different than when you just had the company and use the connectivity for just surfing the web, or connecting to the email clients, and from time to time some Dropbox or OneDrives. So connectivity issues are very, especially if you have mission critical workloads in there, and you have to calculate also the the usual traffic, that is the operating traffic, that is everyday traffic, about the users connecting to the cloud storage or cloud services. Plus, then you have to also consider the connectivity when the things go bad, and that is when you need to restore things, when you need to, for example, if you have disaster recovery set up in on-prem or in cloud, or partially in a hybrid. So you have to consider also these scenarios, and consider also having multiple connectivity devices, and multiple vendors, and so on. So because I've seen too many times that the Murphy's Law in practice, and that the things that have been practically impossible that happen, because I've seen the three different backups on three different places go unusable, and the company that depended on it almost lost everything. And also, what we need to address is also to investigate integration and compatibility of the different services. So, especially if you work with different vendors and different and implement different services, you need to investigate how these integrate together, how these services work, and whether they have any compatibility issues. And especially don't rush, take time to plan. 80% of planning and 20% of execution is roughly what you need. And What we have next, we have also.
Okay, so I would like to add a couple of things on this one. Like connectivity, integration, compatibility stuff is like really thing of that mostly concentrates on hybrid cloud. And in my past experience, like 90% of the companies I've worked with, they went with the hybrid model of the cloud. They were not able to just like wake up one morning and say, okay, we're moving to cloud completely. For most of the companies, and I said from my personal experience, 90% of the companies did some kind of hybrid. They kept part of the services on-prem, they moved part of the services to the cloud, they started playing with the cloud, and then like step by step started moving the rest of it. But like the first step is like taking leverage of what you already have and then like expanding it on the cloud based on that, like using the best from both worlds. And it's been quite like that for quite a few years. I've seen it for, I don't know, for like at least last 5-6 years. Now, last year and like pandemic and situation, new normal as we call it now, changed things a lot on this part. Like we're seeing less and less hybrid cloud. Like a lot of companies are completely moving to the cloud now. What I see developing around, especially in the big company, is not like hybrid cloud anymore, but multi-cloud anymore. A lot of companies are using more than one cloud provider. And this is like where these things are very important again, because you want to consider what is the connectivity between, if you're using AWS and Azure and you have services on both sides, at some time you'll probably need to do some kind of data things or fetch data from one system and get it to another and so on. So these things become a very important part of your ecosystem again. Like consider what connectivity is going to be, like how you choose regions, like this is will impact. Like if you're using Azure region in Europe and decided to use AWS service in US, you're probably going to encounter some performance issues. So you want to consider those things. Also, how services on one side integrate with services on another, and so on.
Yeah, sometimes also I've seen the things. Sorry, just wanted to say that for example, AWS and GCP and Azure, when connectivity was okay, but then when then the throttling was an issue. So everything ping was working and connectivity was there, but when things started going into production, then there were still serious performance issues and in specific scenarios for some applications and databases, etc. So it's not the general thing that has the problems, but the specific implementation. So what I want to say is, don't just ping and say, okay, it's connected, this works, but also test it in a lab, simulate the as much as possible the real scenario.
Okay, last part is with the planning. I get this question a lot from the clients. Do we do change management or quick adoptions? There are pros and cons for both approaches that I've seen. With change management, you're moving things gradually. Like you're moving piece by piece, testing everything, making sure everything will work fine, and then switching. Service by service, you move piece by piece, and good part of this is that you're at the end of the migration. Once you're done, you have a pretty clean solution. Like you knew whole time what you were doing. You took your time to plan. You moved thing by thing on stuff, and basically once you're there, you actually know where you are, and it's exactly where you wanted to be in the first place. The bad part is that users are getting a lot of confusion on what's going on when they're asking for something. Is it still on-prem? Is it in the cloud? Why is this running this way? This wasn't like that. And that kind of, from the user perspective, it creates a lot of confusion. On the other side, quick adoption doesn't have that kind of problem. Like from the user perspective, you do just get over. Like this weekend, we are migrating everything. From Monday, you're on cloud, and users are pretty clear on what's going on. Like if you're not here, we are there. On the other hand, from that where we're gonna be perspective, it's quite different because you just did that cutover. There were a lot of mistakes. There are a lot of unconsidered scenarios, and it's going to take quite some time to actually get things right and get them the way you want. So, in my opinion, I would always go with the change management, but like it depends on the situation and other factors as well. Okay.
And the most used word in the cloud is today is it depends, I think.
Yeah. Okay. So some things that are often forgotten about in the cloud. So Sasha.
We need to design for availability. So it doesn't mean that when we shift to the cloud or implement something in the cloud that our concern about that is over, and so we don't have to think about that. It's for a very specific, very real reason. There is no such thing as even when we buy hardware, our hardware at home is not 100% reliable. So it's the same hardware that the hardware vendors, the cloud vendors also have. So and the availability and the probability of something for failing, it just calculated when you multiply the probability of all the components that are in there. So if you have all components that have 99% point some nines, and when you multiply all that, you will get a number that is less than 100 or less than any of the numbers that are multiplied between themselves. So if you have just multiply 99.9 by itself on square, that is 99.8 or something. So if we have multiple components, then the availability is even less. And then, of course, we have service level agreements. We have realistic things that can happen. Hardware can happen. Hardware failure can happen. So we need to address that. We need to design for availability. So it doesn't mean that something is in the cloud that is going to be there 100% of time. There is no such thing of 100% of availability. It's we have the option to go very near that, but actually then it's very costly to do that. So we have to balance between these two things about the availability and the cost, whether we want actually 15 nines, but do we want to pay like gazillion of euros or pounds or dollars, or we are good to accept couple of hours of downtime a year. And then also take service level agreement and support into consideration. So paying for a little bit for more support actually can pay itself off after a few calls, because if you, for example, if the support is like 2,000 per year, but then your outage of 24 hours or a couple of hours actually is 100,000, then it actually pay for itself. Service level agreements also are there. So each specific feature, each specific service has its own service level agreement, and you need to take into consideration and also see what it is when the specific service has a certain availability and falls under specific 3 nines, 5 nines, 4 nines. So, for example, if you have just one plain vanilla virtual machine, that virtual machine doesn't have a service level agreement. But if you provision it with a premium disk, for example, or put it in the availability zone, then there you have the service level agreement. So you have to take consideration of this as well. Okay. And then
one thing that we often forget is just by putting in the cloud, it doesn't take all of the responsibility from us. We still need to have backups. We still need to have disaster recovery. These kind of like things are especially important if you're aiming for some kind of compliance, either ISO or SOC or whatever. These are kind of important things, but still, again, like having redundant copies of something somewhere doesn't actually mean same thing as backup. Like backup can save your job. Same thing for the DR. If everything goes south, if you have a DR, you're probably good to go because your outage can be like gone in a couple of minutes, and you're back online.
Now, and also you have to consider recovery time objective and recovery point objective as well.
That's very important. The good part is about like backups and DRs in Azure, that like having backup and DR is cheaper than ever. I know, like I did a lot of design of DR systems back in my time, and usually DR system in on-prem environment costs 70 to 80% of original data center. So basically, this is much cheaper now, and it's like achievable in the limit. Okay, speaking of other things that can save your job, enable logs and diagnostics on everything, everywhere, like everywhere possible. Enable logs and diagnostics because they will help you troubleshoot. If something goes south, they will help you to figure out what's going on, where you have issues, and how to resolve those issues. So
you cannot
our lifesaver, definitely have them enabled. They
cannot know what's
a little bit because they're stored somewhere, but that's like peanuts. Like you're paying, I don't know, couple of dollars per couple of terabytes of data. So you don't really need to worry about that too much.
You cannot know what's bad if you don't know what's good. So you have to have the baseline.
Okay, and scalability. It's a great thing. It's amazing thing, but you need to be careful with it. Basically, when you're scaling out your applications, you're adapting to increased workloads. You have to be careful about it. The two things. First of all, that along with the scale out rules, you create scale in rules. So basically, once your workloads are done, you actually want to go back to original point, like what you're running when you don't have so much users hitting your application. On the other hand, also very dangerous is that if your application is scaling because of bad application, if you have memory leaks and bad architecture, and your like application is just jumping through the roof, and additional instances of your application over time, you're just paying a lot of money for bad application because you're resolving memory leaks, not getting more money because more users is using your application. So be very careful about it.
And there's a question in terms of effort. How much consideration needs to be given to security and securing your cloud services infrastructure?
I'm sorry that we don't have too much time for that one, because like this is my Sasha's and mine's favorite topics. We could talk about security for years. Sasha is also a certified ethical hacker. I did a book on Azure security. So basically, we can do a lot of talk about it. But basically, what we need to remember is like, because of when cloud became a thing, when it came out to the market, a lot of people had mistrust with the cloud, and everyone was like, where is my data going? Who's gonna look at my data, and so on. And as a result of that, like all cloud providers advertise cloud as very secure. Like your data is going to be more secure than ever. Like it's going to be more secure than in your data center. And it's true to some extent, but we need to keep in mind that cloud works on something that is called shared responsibility. Cloud provider is responsible for your data, for security of everything, up to a certain point. They are responsible for the physical security of the data center itself. They are responsible for hardware security, encryption, like what happens to the data at rest, and so on. And they have top of the security on that part. So like something that most of the organization, maybe like military or some government agency, could achieve. But like 99% of the companies or of organizations will never achieve that kind of security when it comes to that part. Now, when it comes at a certain point, responsibility is actually transferred to us because, okay, we put our data in the cloud and it's secure there, but we created like an application that is really vulnerable to SQL injection. Like we cannot pin that one to a cloud provider really, because it's kind of like our own issue. We created a bad code, or we just like login for our application is so weak and like anyone can get in and get our data or whatever. There are like million different scenarios, and we have to take part of that responsibility on what's going to happen, like how we use those services. All those services have some kind of built-in security feature. Like, for example, on Azure App Service, you have option to auto-integrate. Like in just 2 clicks, you can integrate Azure Active Directory login in your application, or you can enable HTTPS enforcement just one click, or which version of TLS you want to use, and so on. So basically, and each of the applications, like each of the services in Azure has those like security enhancements that you can use. And you know, the other, on top of that, we have like security dedicated resources, the security dedicated services that you can actually use to enhance your security. But it's up for us to actually use them and improve the security of our applications and systems. Okay, just a couple of final notes. Definitely consider secret management in Azure. Key Vault is a lifesaver, how you're gonna save your secrets and everything else. Always use MFA, especially for the admin accounts. But like I would put like MFA as a default for all users today, because cloud identities are really vulnerable. Leaking credentials can lead to catastrophic situations, and MFA makes it a big time better. Like it's not like 99.9 security better, but like it's much better. And finally, try having naming conventions and governance in your environments, because when you have a bunch of resources, it's really hard to track who is using what and how. So try to figure out how you want to put names so you can actually recognize the services and to which systems and departments they actually belong. Okay, we rushed through it at the end, but thank you for your time, and we will be on Slack if you have any additional questions for us.
We'll be back. Yeah. Okay, so if you have any questions, please don't hesitate to contact, and thank you for being here. Enjoy the rest of the conference. Thanks. Bye.